Good afternoon, students. Today I am going to explain the differentiation of inverse trigonometrical function so you can easily complete this exercise in this break. Now here let me explain. Yesterday I have told you about the derivative of inverse trigonometrical function. Let us see their use. Now we have to differentiate these different functions. Let us see the first part. Let we assume let y equal to sine inverse x cube. Now dy by dx. Yesterday I have told you the derivative of sine inverse x is equal to 1 upon under root 1 minus x square. Now here our x is x cube. Therefore the derivative of sine inverse x cube is equal to 1 upon under root 1 minus x cube square into derivative of x cube. So it becomes dy by dx equal to 1 upon under root 1 minus x raised to power 6 into 3x square. Now see the next question. Let us differentiate y equal to tan inverse cot x. All these questions will be explained by the chain rule. Now again dy by dx, the derivative of tan inverse x is 1 upon 1 plus x square. Now here our x is cot x. So therefore its derivative becomes 1 upon 1 plus cot square x into derivative of cot x. Now we know the derivative of cot x is what? Minus cosecant square x. And also we know 1 plus cot square x is cosecant square x. So our answer is equal to minus 1. See the similar question here. Y equal to sine tan inverse x. Again our first function is sine. And the second function is tan inverse x. Again applying the chain rule here. Therefore dy by dx, the derivative of sine is cos. This will act as x. Therefore it is what? Cos tan inverse x into derivative of tan inverse x. Putting these values, cos tan inverse x into 1 upon 1 plus x square. Similarly, see the differentiation of y equal to under root tan inverse x square. Now we are here having three functions. One under root, second tan inverse, third is x square. We are having the chain of function. Now this can be written as tan inverse x square whole power 1 by 2. So first we have to start differentiation by the whole power. Therefore dy by dx is, it can be written as 1 by 2 tan inverse x square as it is whole power 1 by 2 minus 1 into derivative of tan inverse x square. Now it can be written as 1 upon 2 under root tan inverse x square into derivative of tan inverse x square. So our x is here x square. The derivative of tan inverse x square is 1 upon 1 plus x square whole square into derivative of x square. Then simplifying it, we are having here 1 upon 2 under root tan inverse x square into 1 upon 1 plus x raised to power 4 into derivative of x square is 2x. Simplify it and then we can write our answer. Now here one of the important questions, and similar question we have done also in the inverse trigonometrical function. Now the question is y equal to tan inverse cos x upon 1 plus sin x. Now in this question, always in the question of inverse trigonometrical, if the direct result cannot be applied, so first we have to simplify the given function such that if there is tan inverse, it becomes tan. That we have done in the inverse trigonometry also. Now we have to apply some results so that this whole expression can be written in the term of tan. Now it can be written as tan inverse as it is. Now just see cos x can be written as cos square x by 2 minus sin square x by 2, because we know cos 2 theta is cos square theta minus sin square theta. So cos x can be written as cos square x by 2 minus sin square x by 2. Again in the denominator, if here is the half angle, in the denominator there must be the half angle. So therefore one can be written as cos square x by 2 plus sin square x by 2. And this sin x, again by using the multiple angle result, this sin x can be written as 2 sin x by 2 into cos x by 2. Now our expression becomes y equal to tan inverse. We can make the factor using a square minus b square, and the denominator can be written as a square plus b square plus twice ab equal to a plus b whole square. Now just cancelling the common factor from the numerator and denominator, we left with tan inverse cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 is equal to tan inverse. Again dividing numerator and denominator by cos x by 2 because we have to convert this into tan. So it becomes 1 minus tan x by 2 upon 1 plus tan x by 2. Then again using the result tan, it can be written as tan inverse. It is what? Tan pi by 4 minus x by 2. It become what? Tan. So they will cancel each other. It become pi by 4 minus x by 2. Now this is our y. Only till now we have simplified our y. Therefore its derivative is dy by dx. The derivative pi by 4 constant term is 0 minus the derivative of x by 2 is 1 by 2. Therefore, dy by dx equal to minus 1 by 2. This type of questions are always important either in the inverse trigonometrical function or in the differentiation also. This type of question will do in the integration also. So, this step is very much important, how to simplify this function to get the tan. Now see the similar question again, y equal to sine inverse 2x under root 1 minus x square, x lies between these. Again here is sine inverse, we cannot apply the direct result here in the question. Now here it is sine, so it must be in the sine. Now already I have told you, whenever we are having under root 1 minus x square, always we have to put x equal to sine theta. This substitution I have done in the inverse trigonometrical function also. Now putting x equal to sine theta, then y becomes sine inverse 2 sine theta under root 1 minus sine square theta. Then it becomes sine inverse 2 sine theta into cos theta. Now it is the result of sine 2 theta. We left with what? 2 theta. Putting the value of theta here, it is what? 2 theta is what? Sine inverse x. Now we can easily differentiate it, y equal to 2 sine inverse x. Therefore, dy by dx is 2 upon under root 1 minus x. Now see the next question, y equal to tan inverse under root 1 minus x upon 1 plus x. Now I already told you, when this type of function is there, we are having 1 minus x and 1 plus x together. Then always we have to put x equal to cos theta or cos 2 theta. Now again putting here x equal to cos 2 theta. Then it becomes tan inverse under root 1 minus cos 2 theta upon 1 plus cos 2 theta. Tan inverse using the result 2 sin square theta using 2 cos square theta. It becomes tan inverse tan theta is equal to theta. Then again putting the value of theta here. Now x equal to cos 2 theta. Therefore 2 theta is cos inverse x and theta is 1 by 2 cos inverse x. Putting this value of theta here, we are getting y equal to 1 by 2 cos inverse x. This implies dy by dx is 1 by 2 as it is. Now we know the derivative of cos inverse x is minus 1 upon under root 1 minus x square. This is our answer. Now see, let us one of the important question of inverse trigonometry here. Differentiate y equal to this whole expression. Now see, let us see this question, how to do it. Always this type of question you have to keep in mind how to start the question. Now here what we have to do it, we are just putting x equal to sine alpha so that under root 1 minus x square becomes under root 1 minus sine square alpha. It is equal to cos alpha. And similarly we are putting under root x is equal to sine beta. When I am taking under root x equal to sine beta, then this expression under root 1 minus x becomes under root 1 minus sine square beta because x can be written as under root x square. Therefore, it becomes under root 1 minus sine square beta. Then this is equal to cos beta. Now putting all these values in the expression, y equal to sine inverse sine alpha into cos beta minus sine beta into cos alpha. Now we are having the result sine A cos B minus cos A sine B equal to sine A minus B. Now both are the same function. So this is equal to alpha minus beta. But alpha and beta we have to assume ourselves. So we have to eliminate it. So alpha can be written as sine inverse x and beta can be written as sine inverse under root x. Now this is our y. Again differentiating with respect to x. It is what? The derivative of sine inverse x is 1 upon under root 1 minus x square minus the derivative sine inverse under root x is equal to 1 upon under root 1 minus under root x whole square into derivative of under root x. Now it is what? 1 upon under root 1 minus x square minus 1 upon under root 1 minus x into the derivative of under root x is 1 by 2 under root x. Then this is equal to 1 upon under root 1 minus x square. Now these two terms are like term, we can easily collect them, equal to 1 upon under root 1 minus x square minus 1 by 2 under root x minus x. Again I am saying this is the one of the important question. Now this was all about the differentiation of inverse trigonometrical. Now you can easily try the question from the exercise. Now see